All right, we're going to be going over the organic reactions in chemistry. You're going to have to find what the products are for each of these reactions. So we're going to start with substitution. And this is for alkanes only, meaning that they're all saturated hydrocarbons with all single bonds. So for instance, we could have ethane, 2 carbons, 6 hydrogens. And we must add a diatomic molecule. So this could be any halogen. So what you most commonly will see would be Br2, Cl2, I2. These are all halogens, and they're all diatomic. So another name for substitution, if you have one of these three, would be halogenation, because you're adding a halogen, or you're substituting a halogen. So let's say, for instance, we have Br2 here. The products you would see would be, you would substitute one of these bromines in for any of these hydrogens. It doesn't matter which one. And the other bromine would attach to that hydrogen that came off. So one bromine would go to this hydrogen, and then the other bromine would go to this hydrogen that came off. So you would have Br there, and you would have this H come with this Br. So you would see that the product would be, you'd have a Br here instead of a hydrogen, and all the rest would stay the same. And it doesn't have to be that place in particular. It could be any of these hydrogens. But since you had a diatomic, you have 2 bromines, so the other bromine would attach to the hydrogen that came off, and that would be HBr. And let's say, for instance, you had a diatomic but with a coefficient of 2, you would substitute 2 bromines. So whatever the coefficient of the diatomic molecule is, that's how many atoms you substitute in. So here we would substitute 2 bromines. So say we would substitute the same one again, but then also that hydrogen on the other carbon. So this would be bromine. And since we have a total of 4 bromines, which is just the coefficient times the subscript, we have a total of 4 bromines, and we substituted 2 in and 2 hydrogens came off. That means that we have 2 bromines left and 2 hydrogens that came off. So this coefficient would also be 2, because you have 2 hydrogens that came off from these 2, and you have 2 bromines left from the 4 that you originally had. And that's substitution. Once again, only for alkanes. The next reaction is addition. And this could be for alkenes or alkynes. So only for unsaturated hydrocarbons, which means that you're going to only use addition when you see a double bond or a triple bond. So let's say, for instance, you have this molecule, ethene. So you have you have 2 carbons, 4 hydrogens, and you have a double bond in the middle there between the 2 carbons. So since you have a double bond, you know it's an alkene. And once again, you're going to add a diatomic molecule. So let's say it's I2 this time, iodine. What would happen would be, you would just make this bond one less. So you would turn a double bond into a single bond. You would break one of the bonds. So, and if this was a triple bond, you would break it down into a double bond. So either way, you're freeing up one extra bond for each carbon, like one extra atom for each carbon to bond to. So here, we would turn that double bond into a single. That would free up one more place on each carbon for a bond to happen. So all the hydrogens would stay the same, you just free up room for these iodines to bond since you broke one of these double bonds here. And each carbon can only have 4 bonds. So this is 1, 2, 3, 4. And for the right carbon, 1, 2, 3, 4. But if you have a double bond, that's 1, 2, 3, 4. So it will not be able to have these iodines on it. But once you break that double bond, you can. But let's say that you didn't add iodine. Let's say you added hydrogen, H2. This is known as hydrogenation, and it's pretty much the same exact concept, but instead of having a halogen, you have hydrogen. So this would turn it into ethane. And this is known as hydrogenation. When you're adding just hydrogen to an alkene or alkyne and just allowing it to become more hydrogenated, meaning it has more hydrogens on the hydrocarbon or on the organic compounds. Next is condensation. And when you think condensation, you have to think water, meaning that H2O is one of the products. So every time you have condensation, you know that H2O will be one of the products. So let's say we have 2 alcohols. So this is methyl, and then over here could be ethyl, or ethanol, methanol and ethanol. So what you would do here is you would take one of these hydroxyl groups and the hydrogen from the other hydroxyl group. And you could see that you have 2 hydrogens and 1 oxygen. So this could be written as H2O. And you take that out of the equation, or out of the 2 organic compounds. So that's one of the products right there. And the other one could just simply be you combining these 2 hydrocarbons. So it would be, you would just remove those 2 hydrogens and that oxygen and just put together the other 2 organic compounds. So in this case, it would be, you would have an oxygen there, and then so in this case, you're making an ether here. And an ether is just 2 hydrocarbons brought together by an oxygen. So you would have H2O as a product and an ether as another. And another reaction, which is going to be our last one, is esterification, which can also be seen as a condensation reaction, but the primary product of this is an ester, which is what you're trying to make. So in this reaction, you would have an alcohol added to an organic acid. So we could have, or I'm going to write it an organic acid added to an alcohol just because it's a little bit easier to write it that way. So this is our organic acid. It has the carboxyl group, COOH, at the end of it. And we're going to have an alcohol over here. So this is ethanoic acid on the left here. I'm going to write that down. So you have ethanoic acid, which is an organic acid, added to, let's make this propanol. propanol, which is an alcohol. And what you would do here, which is pretty similar to what you did before, you would take the hydroxyl group from the alcohol and take the hydrogen from the organic acid. So you always take the hydroxyl group from one of the alcohols. So in the last case, which was condensation, you would take it from any of the two alcohols. But in this case, you only have one alcohol to take it from, so you must take it from this alcohol. And you take the hydrogen from the organic. So this leaves you with H2O as a product again, which is why I say that this is also a form of condensation. So that's one of the products, H2O. And you would do the same thing. You would just combine the two compounds or molecules. You would leave that double bond on the oxygen, and you have another oxygen left over still, and you would just add that on to the rest of this chain of carbons. So last time we had an ether or an ether as one of the products, but this time we have an ester. And the way you would determine that is by looking at this functional group, COOH, or COO, no H. And the way you would name this would be, you would take the compound or the molecule that is substituted for the hydrogen in the organic acid. So you see how this hydrogen in the organic acid, you could say, was replaced by this carbon. You would name this side first. So this would be propyl. And then you would name the other side that wasn't really changed much except for that it lost a hydrogen. So this would be ethane. And instead of having oic acid, you would do O8 because you lost the hydrogen. So it's an ester. And that's pretty much it.